Timeless Concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question on finding the current through a given resistance in a series parallel network. The question is as follows. Read the question carefully. The series parallel network of resistances is shown in the figure. There are 4 resistances, 6 ohms, 3 ohms, 2 ohms and 4 ohms. Now 6 and 3 are connected in parallel and the 2 ohm is in series with this parallel combination. And 4 ohm resistance is in parallel with this upper branch. And the whole system is connected across a cell of EMF 6 volts and negligible internal resistance. We are required to find the current flowing through this 3 ohm resistance. Now for the answer. First of all, we'll determine the total resistance of the circuit. Using this and the EMF of the cell, we will determine the current drawn from the cell. We have denoted it by I. So, first of all, the equivalent resistance of 6 ohms and 3 ohms in parallel. So we denote it as R63, which is equal to 6 into 3 divided by 6 plus 3, which is equal to 18 divided by 9, or R63 is equal to 2 ohms. In the simplified figure, we have replaced the parallel combination of 6 ohms and 3 ohms with a single resistance of 2 ohms. Now, this 2 ohm and 2 ohm are in series, therefore, the equivalent resistance will be 4 ohms, which is written here, denoted by R22, which is equal to 2 plus 2, which is equal to 4 ohms. This, in the simplified circuit, this 4 ohm is shown in place of the 2 ohm resistances in series. Now we have 4 ohm and 4 ohm in parallel. Therefore, the total circuit resistance, because the combination, the equivalent resistance of 4 ohm and 4 ohm in parallel will give us the total circuit resistance R, which is equal to 4 into 4 divided by 4 plus 4, which is equal to 2 ohms. Therefore, current drawn from the cell will be equal to total EMF divided by total resistance. So, total EMF is 6 volts and total resistance is equal to 2 ohms, and the internal resistance of the cell is equal to 0. It is given in the question. So dividing, we get I is equal to 3 amperes. Now we observe that the 2 branches, because current I is divided between the 2 branches, I1 and I2, I1 flows through the upper branch, which is 4 ohms resistance, and I2 flows through the lower branch, which is also equal to 4 ohms. Therefore, the current will be equally shared by these 2 4 ohm resistances in parallel, which gives us that I1 is equal to I2. But I1 plus I2 is equal to I. Therefore, each of them is equal to half of I. That is, I1 is equal to I2, which is equal to I by 2, which is equal to 1.5 amperes. Now coming back to the original given circuit. Now we are focusing on this part of the circuit because we want the current through the 3 ohm resistance. Now before that we want to find out the potential difference across the parallel combination. Now the resistance of the parallel combination is equal to 2 ohms, which we have already found, and current through this parallel network is equal to 1.5 amperes because I1 is equal to 1.5 amperes, so also I2. But we are interested in I1 only because I1 multiplied by the resistance of the parallel combination will give us the potential drop across the parallel combination. Let us find that. So we denote it as V63, means the potential difference across the parallel combination of 6 ohms and 3 ohms, which is equal to current through the parallel combination, which is I1, multiplied by resistance of the parallel combination, which is R63. I1 is equal to 1.5 amperes and R63 is equal to 2 ohms. Multiplying, we get V63 is equal to 3 volts. Now V63 means voltage across the parallel combination is equal to 3 volts. That means voltage across the 6 ohm is also 3 volts and voltage across the 3 ohm resistance is also equal to 3 volts. We are interested in this. So voltage across the 3 ohm resistance is 3 volts and its resistance is 3 ohms. Therefore, current through the 3 ohm resistance is given by I3 is equal to 3 volts divided by 3 ohms, which is equal to 1 ampere, which is the answer to the question. Therefore, the correct option is C. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.